All right, we're going to move on to independent events, and this example will just have us identify them, and then we'll end with finding the probabilities of independent events. So, independent events, let's put a definition in here. This is the occurrence of one event does not affect the probability don't know what that is. Probability of a second event. All right, so independent events, this is the occurrence of one event, does not affect the probability of a second event. All right, so our example, we've got a jar that contains 12 green marbles and 8 violet marbles. It's always nice just to do a little prep work and say, all right, so that means that we have 20 total marbles. Anytime we get into probabilities, we always need that total. All right, part A, a marble is chosen at random from a jar and replaced. Let's go ahead and circle that. I think that's going to be important. Another marble is chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? Well, let's take a look at it. So our first marble, what are our possibilities here? You could choose a green marble. So what's the probability of choosing a green marble? Well, there are 12 green marbles over 20 total. That reduces to 3/5. Divide both of those by 4. The probability of choosing a violet marble is 8 out of 20, which reduces to 2/5. All right, so what we're assuming is that we pick a marble, but then we put it back. We're going to replace it. So the second marble, let's see what our options would be there. So the probability of choosing a green marble. So whatever we chose the first time got put back. So there are still 12 green marbles in a jar, and there are still a total of 20. So there's still a 3/5 chance of choosing a green marble. The probability of choosing a violet marble, well, whatever color we picked here got replaced. So we still have 8 violet marbles out of 20 total, which is 2/5. So what we're just checking on here, the color of the first marble that was chosen did not change the probability or the possible outcomes for the second marble chosen. See how we still have a 3/5 probability for the green or a 2/5 probability for the violet marble. So the color of the first marble chosen does not affect the possible outcomes for the second marble chosen. So that means that these are independent events. Whatever we're doing with the first marble, because it got put back, does not have any impact on which marble we choose second. Okay, so what would this look like if maybe the events were not independent? So a marble is chosen at random from a jar and, uh-oh, not replaced. Another marble is chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? Well, let's see. Why don't we just run through this again? So what are our possibilities for choosing the first marble? So we said this before, that the probability of choosing a green marble was reduced to 3/5, and the probability of choosing a violet marble was 2/5. All right, so that was our first marble. Now, the outcomes for the second marble chosen, well, let's just say that the first marble chosen was green. So if the green marble was chosen first, then what are outcomes for choosing that second marble? Well, the probability of choosing a green marble, so we chose a green marble here, but then it did not get replaced. So we had, or maybe I should have written those in, we had, remember, 12 green marbles. Well, one of them got chosen as the first marble, so we're down to 11 green marbles. And because that green marble was not put back in the jar, we have 19 marbles left. So we have an 11 out of 19 possibilities for choosing a green marble. What about the probability of choosing a violet marble if the first marble chosen was green? Well, if the first marble was a green one, then we still have 8 violet marbles, but we don't have 20 left in the jar. We are down to 19 left in the jar. All right, so that was if the first marble chosen was green. What if a violet marble was chosen first? Then what would our second marble outcomes be? Well, probability of choosing a green marble, if the violet marble was first, we still have 12 green marbles in the jar. But because we chose a violet marble first, we only have 19 left in the jar. The probability of choosing a violet marble, if the first one was also violet, well, we started with 8 violet marbles. We chose a violet marble first and kept it, which means that there are 7 violet marbles left in the jar and only 19 total marbles. All right, so what we're noticing is, did our probabilities change? Did what we did with the first marble have any impact on the second one? And yeah, sure did. When the second marble is not replaced, or when the first marble is not replaced, the color of the first marble chosen does affect the possible outcomes for the second marble chosen. These are what we call not independent events, or you call them dependent events. The probability of the second marble chosen depended on what happened with the first marble being chosen because that marble was not replaced. All right. If A and B are independent events, then the probability of A and B occurring will be the probability of A times the probability of B. We're going to get into this in the next example, actually finding the probabilities. And if you know that the probability of A and B is equal to the probability of A times the probability of B, then that means that A and B are independent events. So it kind of goes both ways depending on what you know first.